The last video I taught you how the matrix are formed, okay, and how to access them, what is a how the size has been decided. All this we talked about it, okay. If you have not watched the video, please watch the previous video, then come for the session. You'll understand better, okay. See, if I say in the last class we spoke like this. If I say integer a of 3 4, what we said was there is a double pointer called a is created, correct. Then there are three single pointers are created, and then 3 into 4, 12 blocks are created of type integers. All the 12 blocks are stored in an adjacent memory, correct. Then what the system does, we said it takes the first address of every fourth block and puts it in this 115 here, 131 here, 147, right. It puts the first address of every fourth block, correct. And then it puts the first address of this in the double pointer and converts into a constant pointer and pointer to a constant. A is a constant pointer as well as a pointer to a constant. Whereas this A of 0 is a constant pointer. A of 1 is a constant pointer. A of 2 is a constant pointer. Right? This is what we spoke. Now, if you want to access this block, what we said was this we consider as a zeroth row, first row, second row. This is zeroth column, first column, second column, third column. Correct? We said the row index starts with 0, ends with row size -1. The column index starts with 0, ends with column size -1. Now, last class we initialized at the line of declaration. Okay, line of declaration. Now, if I want to initialize this block, what we said was, we said A of 0, 0 is equal to 10. Then 10 is stored. If you want to initialize this block, we said what? A of 1, 3 is equal to 30. 30 is stored, right? And we know how it has been derived. Last class we spoke. If you want to access this block, we wrote what? A of 2, 1, right, is equal to, I put some value for 40 is stored. This is what we studied. Okay. No, sir, I want to scan the value for each block. If you want to scan the value for each block, what I should do? I can scan from the user. I can scan from the user here. Okay. Now, how will scan from the user? If you want to scan from the user, first is I scan for what? I need to scan for this block. Correct? Now, scan up %d. What I should put here? I need to put, if I want to put 10 here, I need to give the address of this. How to get the address of this? This block is A of 0, 0, and we put an answer. Correct? Why? Because A of 0, 0 was referring the content, but when I scan, what I need to provide an address. If you want to scan for the next block 119, I need to provide. How to provide 119? A of 0, 1 you need to put. Next A of 0, 2 I need to put. That means what I need to put? I need to substitute a variable here. There the variable will start from j is 0. J is less than 4. J plus plus. Right? If you want to put a statement here, enter a value. You can write enter a value. By this what you've done? A of 0, 0 I entered a value. A of j became 1. A of 0, 1 I entered 20. J became 2. A of 0, 2 entered 30. J became 3. I entered what? 40. J became 4, false I came out. Now what I need to go for the next one. If you want to go for the next one, what I need to put a 1 here. If you want to put a 1, what I should put? I need to put a for I is equal to 0. I is less than 3. Then the next value. Enter 11, 12, 13, 14, 19. When I became 2, J is 0, 0 is less than 4. 2, 0 means this block I entered 15, 16, 17. Now, sir, I want to scan for n rows and m columns. If you want it m rows and n columns, what to do? You can't put your m and n here because the size has to be a constant. We said last class. That means you can enter maximum 10 rows and 10 columns, but you restrict it. Okay, I put R and C. R for row, C for column. What to do? Scan the R. I %d. I put and R and what? C. Declare R and C. You can write enter a rows and columns. Okay, I'm going to show you on this. Now what I need to do next is if you want to print it. If you want to print what I need to do, I need to see one block. Whenever you want to see one block of a matrix, you must have a nested for loop. Okay. Whenever you want to see one block of a matrix for any processing, you must have a nested for loop where the outer loop will deal with the row, inner loop will deal with the column. That means if you want to print it, I want to see one block. If you want to see where outer loop deal with the row, inner loop deals with the column. column. Therefore, I put here for j is equal to 0, j is less than c, j plus plus. I'm going to say print at percentage t slash 3 comma a of ij and printf slash. Got it? Done? Yeah. Remember, whenever you want to access a matrix row by row, in other words, whenever you want to see all the blocks of the matrix row by row, keep the row loop out, column loop in. Okay? If you want to see the matrix column by column, keep the column loop out and row loop what in. Okay? How? I'm going to show you. Okay? I'm going to show you in some time. Okay? Let us see here in this cases. I want to see when I run, if I want to print all the elements, I see one block, correct? Therefore, I want to see row by row. Therefore, I put where I is 0, 0 is less than 3, j is 0, 0 is less than 4, a of 0, 0 means I got 10. J became 1, 1 is less than 4, I put 20. J became 2, a of 0, 2 is 30. J became 3, he put 40. J became 4, false, I came out, print a new line, go for I plus plus, I became 1. 1 is less than R, J is 0, 0 is less than 4, A of 1, 0 means I got 11, J became 1, A of 1, 1 means I got 12, J became 2, I got 13, J became 3, I got 14, J became 4, false, I came out, then I printed a new line, I became 2, 2 is less than 3, I came inside, again J is 0, 0 is less than 4, I did the same thing. I put 15, 16, 17, 18. Got it? Yeah. Okay. So let's go and type it and see what is happening. Okay. See, with this one we saw that, okay, if I create an array of 3, 4, I created a matrix of size 3, 4, and I asked the user to enter the rows and columns. Okay. Remember that I fixed the row and column is only 3 and 4. That means you can't enter maximum 3 and 4 you can't enter. If you want to enter more than that, then you put 10 and 10. Then still again you can enter only 3 and 4 rows. Okay. Then you scan it. I scan the value on one block and I print it, and I'm going to show you how it is looking. Okay. Yeah. So let us see. Let us run the code and see. Enter the number of rows and columns. I put 2 and 3. I'm going to 2 rows and 3 columns. 1, 2, 3, 4, 5, 6. I got it. Yeah. So I got 2 rows and 3 columns. I got this. Got it? Now, if you know, sir, enter a value for this row, this column. What to do? Enter a value for percentage D row and percentage D column. And what is a percentage row? Row is what? I. And J plus 1. Why I put I plus 1? Because we don't say 0th row. We say first row, right? So enter the number of columns in this 2 and 4. I entered 1, 2, 3, 4, 5, 6, 7, 8. Got it? Got it? I hope you understood that. Right? Okay. Done. So now, whenever you write a program on matrix, okay, don't use this approach of scanning values. Okay, always put a comment on this. At the end, what you do is to verify that. At the end, you open the comment and what? Test. Still that what you do, initialize the values only directly, because don't waste your time in entering values. Okay, I am going to enter 3 rows and 4 columns. So what to do? 1, 2, 3, 4, 3 rows and 4 columns. 5, 6, 7, 8, 9, 10, 11, 12. Yeah. See, and now R and C is what? Initialize directly. 3 rows and 4 columns. The rest of things you can remain same. I entered here. I want to run the code. I got it. Okay. Now look at this. Now we have an input. We have a output here. Now I am going to talk about the process. Okay. Let's talk about the process part. Okay. Let us see. So I have been given a matrix. Here. So I entered a matrix of size 3 rows and 4 columns. Right? So this is, we know this is the 0th row, first row, second row, 0th column, first column, second column, third column. What I wanted, okay, I want the output to be printed like this. Okay, I want to print the matrix along with the sum of the rows. Okay. Now what I need to do, if I want to print the sum of the rows, I want the output to go like this. 1 I want to print, 2 I want to print, 3 I want to print, 4, and equal to, I want to put here in this case is 10. Then I want to print 5 plus 6 plus 7 plus 8, that is 26 I want to put here. 9 plus 10 plus 11, that is how much, 30 and 42 I want. Now tell me, to do this exercise, did you see all the elements? How many times you saw? Once. How did you see? Row by row. Okay. First you saw the first row, then the second row and the third row. Correct? Therefore, what you need to do, if you want to see row by row, keep your row loop out and then column loop is in. But what I need to do, after printing these elements, I also need to print the sum. But the sum variable, next time when I go back, the sum variable has to become what again? I need to start again from the beginning because I need to add 5 plus 6 plus 7 plus 8. Correct? Therefore, simple thing. If you want to see all the elements row by row, what I should do? What we said, keep the row loop out, column loop what? In, right? But what I need to do, yes, I need to print the matrix. Yes, the same is appearing. But what I need to do, after printing 4, I need to print the sum of this. That means what I'm going to do. The sum needs to be initialized to 0 for every row. Therefore, I'm going to sum here. Initialize towards 0 here. What I want to do, sum plus equal to A of Ij. I added every time, and before going to the next line, I need to put with the sum. With the equal to sign, I need to put the sum. Percentage D, comma what? Sum. What to do? That's it over. Got it? No, sir. I also want to print like this. I also want to print the column sum I want to print. Sir, I want to print the column sum. What is a column sum? If I want to print it, 1 plus 5 plus 9, how much what? 15 here. 2 plus 6 plus 10 is what? 18 here. 3 plus 7 plus 11, how much it is what? 21 here. 4 plus 8 plus this, how much it is what? And then I want to print this total sum. Total sum is sum of all the elements. Sum of all the elements would be how much it is what? 10 plus 26 plus 42, or you can add this also, right? Now, anything will do. Therefore, it is 48, 68, 7. Correct? I want to do. Correct? Okay, now let's go. How to do that? Let us see here. Now tell me, if we want to find the column sum, I saw all the element column by column. After completing this column, I went to the next. After completing this, I went to the next. Correct? What I'm going to do here, this, put the column sum. So if you want to see, first is what I did. First time we added 0, 0 with what? 1, 0 with what? 2, 0. What is changing here? The row is changing. The column remains constant. Next time, I need to add what? 0, 1 here, 1, 1 here. What I change? The row is changing. What is changing? That remains constant with the column. Therefore, now what I'm going to do? If you want to see the matrix column by column, keep the column loop out and row loop what? Inside. What I'm going to do? After printing that elements, after printing that, I need to print again the column sum. Control C. Column, keep it out. Integer J0, J is less than C, J plus plus. Right? I need to find the column sum. I is inside, I is less than R, I plus plus. A by J, but I don't need to print the element every time, right? I need to print only the sum at the end, right? So, but after printing one sum, do we need to go to the next line? No need. I have to keep on printing all the sum in the same line. Therefore, I put a slash T here. I put a this here, code. Yes, I got it. But what happened is, here there is a tab here there is a equal to sign and tabs. What I'm going to do, I don't need this here. I put only the tab. Correct? Now let's see whether it's aligning. Yes, right. Now what happened is my next is here in this case is I want the total sum here. The total sum at the end. So what is the total sum? Sum of all the elements. If you want to find the total sum, that variable needs to be initialized how many times? Only once. Why? Because all the elements I need to find the sum. Therefore, I'm going to create here something called total. Total is equal to 0. And here what I'm going to do here in this case, total plus equal to A of ij, right? And outside, I'm going to print the total. Printf percentage D, comma what? Total. Got it? You want the equal to sign? Yeah, you can put the equal to sign. If you want, you can put this right now. Got it? So whenever you want to visit the matrix row by row, keep the row loop out, column loop in. If you want to visit column by column, keep the column loop out and row loop what? Inside. Simple thing. Okay? Yeah. Let's solve another problem. Okay.
So if you like my session, kindly share, subscribe and like.
Okay. I have been given a square matrix. I've been given a square matrix. What I wanted, I want to print only the diagonal elements. Only the diagonal elements. Okay. I've been given a square matrix. I need to find the diagonal element. I need to print only the diagonal elements. Okay. But I want to print the diagonal. Which are the diagonal? Sir, before that, which are the diagonal elements? This is one diagonal. Correct. This is another diagonal. So when you want to solve a problem, first is you take a notebook, write, and see the logic you build first. So what are the elements I need to print here? I need to print 0, 0, and I need to print 0, 3. What are the condition for it? I want to print the diagonal like this only. That means I need a space between them. Okay. Then I need to print. I don't need to print 1, 0, but I need to print 1, 1. I need to print what? I need to print 1, 1, and then I need to print 1, 2, and I don't need to print this. Then I need to go. I don't need to print this. I need to print what in this case? 2, 1. I need to print 2, 2, and I need to print this. Then I need to print 3, 0. No, no, and this is 3, 3. Look at this. Derive the logic. What is the diagonal? This diagonal is what? What is the right? This is 0, 0, 1, 1, 2, 2, 3, 3 is this diagonal. What about this diagonal? 0, 3, 1, 2. Then it is what? 2, 1, 3, 0. You see the relationship. The relationship is this here. The row and column is index is same. Here you look at this. What is the relationship? Sum of the row and the column is what? Sum of the row and the column is what? Is 3. What is 3? 4 minus 1. What is 4 size of the matrix? Correct? Therefore, what I need to do? I need to see each element one by one. If the row and the column index same, I need to print. If the row and the column index becomes, sum of the row and the column index becomes a size minus 1, I need to print. Otherwise, you need to print a dash. Correct? Simple thing. Come, let's go. What to do? What we said, it should be a diagonal matrix. So it should be a rectangular matrix. That means I need to put one more. I need to put 12. Right? 13, 14, 15 and 16. Correct? And I go here. If what I should, when I should print, I is equal to j or I plus j is equal to what? R minus 1. And remember, it should be a square matrix. Make a modification. Then you can take the value. See? I is equal to j means it is both are the row and the column is same. I plus j is r minus 1 means the other diagonal. Correct now? But remember, we have not maintained one thing. What we wanted the same format. Sorry, some I did. We wanted the same format. Correct? It won't give me the same format. Why? Why it won't give? Because after going through one line, you went to the next line. Correct now? So you never have a next line here. Printf /n. Second is what he did. If I plus j, I is equal to j or this, you did this. Otherwise, what I need to do, I need to print an empty space. Printf, I need to print what a tab, slash t, close it, and run it. Yeah. So it is a 4 by 4 matrix, correct now? Oh, here I made 3. I'm sorry, it's considered only 3. I need to make it 4. So 4 by 4 matrix. Yeah. I hope you understand this. Okay. Come, let's go to our next problem. Okay, let us understand a problem. Okay. I've been given a square matrix. Okay. I've been given a square matrix. I need to transpose this matrix. I want to transpose the same matrix. Okay. Not I want to store in another matrix. I want to transpose the same matrix. Okay. Let us analyze the problem. Okay. So if I transpose it, what will happen? See, when I transpose, what will happen here? This 2, what is the transpose is? The 0, 1 will go to 1, 0. Right now, ij will become ji. Correct now? So when I transpose the matrix, the resultant matrix will look like this. First of all, let's write the resultant matrix. It will look like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Correct? The row will become the column and the column will become the row. Correct? Now look at this. Let's deeply analyze it. Okay. What I need to do, I need to put the in the place of 2, I need to put the 5. 1 remains in the same place. Okay. 1 remains in the same place, 6 remains in the same place, 11 remains in the same place, 16 remain in the same place. That means the diagonal elements remain in the same place. That means if I and j is same, it remains the same. Okay. Now, in the what is existing in 0, 1 went to 1, 0. What is existing in 1, 0 went to what? 0, 1. What is existing in 0, 2, it went to 2, 0. What is existing in 2, 0, it came to what? 0, 2. Next, what is existing in 0, 3, it went to what? 3, 0. What is existing in 3, 0, I went to what? Now this row is over. Now what do you need to do? Next is what? Now I don't need to worry about this. I need to start here. That means I always need to start elements from after the diagonal. Okay, after the diagonal. So what is existing in 1, 3, 1, 2, it went to 2, 1. What is existing in 2, 1 came to what? 1, 2. What is existing in 1, 3 came to what? 3, 1. What is existing in this? 3, 1 came to what? Now next. What is existing in what? In 2, 3, it went to what? 3, 2. That means I need to get an index above the diagonal. When I get an index above the diagonal, I need to reverse the index, I'll get the other. Remember, I saw all the elements. How many times I saw? Only one. If you want to see all the elements only once, you need to have a nested loop. That's what we said. We need to have a nested loop, right? For I is equal. I saw row by row. Remember, I saw row by row. Or I plus plus. For j is equal to where I should start. See, my row starts with 0, 1, 2, 3, 1, 2. But my column starts with what? First time it starts with 1. When I is 0, it starts with 1. When I is 1, starts with 2. When I is 2, starts with 3. That means simply write what? I plus. How long it went? It went to the column. See, all went to the stopped at 3. I'm not worried about this. Why? Because if I have this, I can get this, right? J is less than C. J plus. Now what I should do? I need to swap them. That's it. What I should do? Integer t is equal to a of ij. When I is 0, j is 1. I get a of ij means 0, 1. A of ij becomes what? A of ji. And a of ji becomes what? T. Swap them. Got it? Yeah? You want to see as a code? Let's go and write the code. Remember, I saw all the elements only once, therefore I use a nested for. But I saw the elements above the diagonal. That's the reason my j started with what? I plus 1. Then what I need to do? When I get the index above the diagonal, automatically get the elements what? Below the diagonal. Let's go and see the code. I need to, right? This is a square matrix. Any square matrix. What we said was my column started one higher than the row. What I need to do? I need to what? Swap it. Integer t is equal to a of ij, right? A of ij is equal to a of ji. A of ji is equal to t, correct? So don't try to print here. Why? Because you are not accessing the elements. You are not accessing the elements in a sequence. You are accessing above the diagonal, but you are getting the elements below the. Therefore, it won't come in order. So what you do? Put in another for to. I put for integer I is equal to 0. Or I don't need to copy paste this loop. Okay, done. And I go here. I say here print percentage d slash t, what a of I say, right? And then I put a, why I put a slash in here? So that after completing every row, how do you know I'm completing every row? I'm coming out of the j loop. I'm going to put a new line. It makes me the new line. It's because see, I put only I start with what? Is 0. Since I put I plus 1, only half of the elements. Okay. Now let's go to the next problem. I've been given a matrix. See, 1, 2, 3, 4, 5, 6. I have been given a matrix of size 2 by 3 and another 2 by 3 matrix. I want to add, this is my A matrix, this is my B matrix. I want to add these two and store on the third matrix. So whenever you get a problem, just write like this in a notebook and analyze it and write a code. So this is 0, 1, 0, 1, 2, 0, 2, right? A of 0, 0, 0, 0 needs to be added with 0, 0 and stored in 0, 0. 0, 1 needs to be added with 0, 1 and stored in what? 0, 1. 0, 2 needs to be added with 0, 2 and stored in. 1, 0 needs to be added with what? 1, 0, 14. And then what? 16. And what? 18. Correct. You saw all the elements how many times? Only once. At a time you saw one element from A, another element from B and stored there in the C. But you saw the index, both the matrix you saw in the same index. Okay, in A also you saw 0, 0, in B also you saw 0, 0, in C also you're going to store in what? 0, 0. Correct? Since I saw all the elements only once, I am going to use a single. But remember, the row and the column needs to be same. Okay, now the size has to be same for addition. I plus plus. For j is equal to 0, j is less than c, j plus plus. What I should do? In c of ij, I need to store what? A of ij plus what? B of ij. Put another for loop and print ABC. Okay, now. So you need to have, remember, your R and C has to be what? Same. Otherwise, you can't add. The number of rows in A number of rows in B has to be same, the resultant matrix size also will become what? Same. Okay, let's solve another problem where we move in the matrix randomly. Okay, so let's see that. Okay, this is called, I'm going to take a problem called magic matrix. What is the magic matrix? Okay, see, I've been given a n cross n matrix where n is odd. N is what? Odd. Let's say in this case I had a 3 cross 3 matrix. Okay, I need to generate a matrix where the sum of the row column diagonal is same. Sum of the row column diagonal is what? Same. Okay, sum of the row column diagonal is same. So what is the algorithm for it? Okay, now the algorithm says like, watch it carefully. Okay, the algorithm says like, place 1 at the first row middle column. Place 1 where at the first row middle column. Next, after placing, decrease the row by 1 and increase the column by 1. If the row does not exist, go to the last row. If the column does not exist, go to the first column. If the generated location is already occupied, go back to the previous position, place it below. Go back to the previous position, place it below. Repeat the procedure n square times, where n is the number of rows and columns, and it needs to be odd. It needs to be what? Odd. Remember that. Okay. So what we spoke was, place 1 at the first row middle column. Decrease the row by 1. See, my first element, my row was in 0th row, middle column was what? In 1. Decrease a row by 1. Increase the column by 1. If the row does not exist, go to the last row. The row does not exist. -1 is not existing. Go to the last row. Yes, 2 is existing. Therefore, place the next element here. Place 2 where? In the next. After that, what I need to do? Decrease the row by 1. Increase the column by 1. Row existing, but the column does not exist. Go to the first column and place it. Excellent. Decrease the row by 1. Increase the column by 1. Decrease the row by 1 and increase the column by 1. 0, 1 is already occupied. What I should do? Go back to the previous position. Go back to the previous position. What was the previous position? Okay. After going back to the previous position, what you do? Place it below. That means simply increase the row by 1. Decrease the row by 1. Increase the column by 1. Decrease the row by 1. Increase the column by 1. Sorry, decrease the row by 1. 0. Sorry, 0, 0, 0. Increase the column by 1. Put what? 6. Next, decrease the row by 1. Increase the column by 1. Row does not exist. Go to the last row. Column does not exist. Go to the first column. 2, 0 is already occupied. What I should do? 2, 0 is already occupied. Go back to the previous position. Who is the previous position? 0, 2. Go back to the previous position and place it below. 0, 2 and place it below. Below means what I should do? Below means I need to increase the row by 1. 1, 2. In 1, 2, place what? 7. Right? Decrease the row by 1. Increase the column by 1. Row exists. Column does not exist. Go to the first column. Place 8. Decrease the row by 1. Increase the column by 1. Row does not exist. Go to the column is existing. Place 9. Sum of the row column diagonal is 15. Right? 8 plus 1 is 9, 15. 8 plus 5 plus 2 is what? 15. 8 plus 3 plus 4 is what? 15. Got it? Yeah? If you have not understood, take your notebook. Listen to this algorithm one more time. Take your notebook and do it by yourself. Okay? Got it? Yeah? So now how do I write a code for this? And here now, I never moved in a row, in a column. I was moving what? Randomly. But one thing I know very well, how many time I need to repeat this procedure is n square time. How long I need to do what? N square time. Where n is what? The number of rows and columns. It needs to be odd. Correct now? Yeah. So what we need to do here in this case is, I'm going to go to the code. Okay, so now my code is going to be, I'm going to ask, okay, I'm going to initialize this to matrix to what? 0. Why? Because how do I know it's empty? I'm going to initialize to what? 0. This I put a comment because I may need it afterwards. You can put any number of rows. Now I need to talk about the process. The process is I'm not going to use a for loop here because I never moved in a sequence. I was moving randomly. I need two things. One is a row index, and one is a column index. Right now, so let's say this is row column. Make it 0. Okay, let it be R. Now I need to know the number of. Rows. N is 4. Any rows? 3 you take. About 3 to take. Then here also need to make it what? I don't want to confuse you. 3n. This is a printing, okay. Now I need to have, one is what? I need to deal with the row. Initially, first row, middle column. How will I write middle column? I need to place 1 at the first row middle column. Yes. Right? First row middle column. What to write? A of R C is equal to K. After placing the element at the first row middle column, n is 3 means n by 2 is 1. Right now, 0, 1 I placed. The next time when I come to execute this statement, my k needs to be increased by 1. Therefore, k plus plus. Now, decrease the row by 1. R minus 1. What to do? Don't store it in R. Why? Because you lose the R. Once you lose the R, you can't get back again. Therefore, what I'm going to do? I'm going to store it in a variable called TR1. Temporary R. TR. Decrease the row by 1 and increase the column by 1. C plus 1. Correct. If the row does not exist, how to write? If TR is less than 0, go to the last row. TR is equal to n minus 1. If the column does not exist, if TC is greater than n minus 1, because n is the maximum, go to the first column. TC is equal to 0. If the generator location is already occupied, how do we know occupied? It's not non-zero, right? Now, if it is 0 means it is not occupied, right? Now, we initialize it what? 0, correct here? If the generator location is already occupied, how do I know? If A of TR and TC is equal to 0, that means it is not occupied. If it is not occupied, my R will become TR. Next time, next iteration, my C will become what? TC. If it is occupied, what we said? If it is occupied, simply what in this case, use the same R and C, but go below. That is what we increase the row by 1. Therefore, only say R plus plus, my C will remain same. Repeat this procedure. How long? Repeat the procedure how long? Till n square time, till k is less than or equal to n into what? N over 1. Right? So keep your indentation right, because you will be troubled if you see. Keep on tab here always. Then you'll understand where the brace got open, where it got closed. Then I've done this. So what I want to print this 4 by 4 matrix. It's a 3 by 3, correct? 3 by 3 matrix. On a 4 by 4 matrix, what I should do? Simply change here 4. Done. Ah, sorry. Number of rows have to be odd. You can't have an even. This algorithm does not work for what? Even. For even, there's a separate logic is there. Yeah. Sum of the row column diagonal is what? 25, 50, 65. 65 is the sum of the row column diagonal. Okay. See here. It's very simple. First is analyze the problem and write a code. Don't try to what? Write a code first. First analyze a problem and come. So okay, let's do another problem. Okay. So I have been given a matrix, two matrices A and B. I need to make C by multiplying A with B and get the C. Correct? For multiplication, what is the rule? The rule is the column of the first matrix and the row of the second matrix must be same. Column of the first matrix and the row of the second matrix has to be what? Same. When it is same, what is the resultant matrix would be? Sorry, when I multiply two matrices, the column of the first matrix and the row of the second matrix has to be same. If it is same, what is the resultant matrix size would be? The row of the first matrix and the column of the second matrix. That means if I say R1 and C1 are the row and column of the first, and R2 and C2 is the row and column of the second, the C1 must be equal to R2 and the resultant matrix size would be R1 into C2. Okay, so how the multiplication happens? If I want a value for C of 0, 0, how I should get it? That means you have two rows and two columns are there. Okay. You want to get a value for C of 0, 0. Correct? How we'll get it? You need to multiply. If you want a value for 0th row, 0th column, 0th row of the first matrix must be multiplied with the 0th column of the second matrix. If you want a value for 0th row first column, 0th row of the first matrix must be multiplied with the first column of the second matrix. Let's say for 0, 0. If you want for 0, 0, how to get a value? The value is going to be A of 0, 0. A of 0, 0 must be multiplied with B of 0, 0. Then you need to add this with A of 0, 1 needs to be added with B of what? 1, 0. That needs to be added with A of 0, 2. A of 0, 2 needs to be multiplied with B of 2, 0. What I observe here, look here, what I observed here. In the first matrix, the column is changing. In the second matrix, the row is changing. How many times I have run? 3 times. That's the reason the row of the first and the column has to be what? Same. 3 times I've done it, right? This C0 is constant. This 0 comes from here. This 0 comes from here. Therefore, if I want a value for C of 0, 0, I can use a loop. This can be converted into a loop. How? C of color field. C of 0, 0 needs to be get a value by a successive addition. Therefore, I initialize towards 0. Now, what I need to do only thing is for k is equal to 0, k is less than 3, k plus plus, correct? Why 3 we said? 3 times I did the procedure. Why this 3 came? The 3 came because I have a 3 rows and 3 columns. That means what is that it was? Either you can use it as a C1 or I can use what? R2. Anything you can use. Instead of this, I can say C1. What I did was in C of 0, 0, I was successively multiplying and storing A of 0k with what? B of k 0. Right? This is what we spoke. When k is 0, A of 0, 0 into B of 0, 0, I get 1. 1 into B of 0, 0 is what? 1. 1 into 1 is 1. I added. Then k became 1. A of 0, 1. What is A of 0, 1 gave you what? 2. And B of 1, 0 gave you what? 3. K became 2. A of 0, 2 gave me 3. B of 2, 0 gave me what? 5. K became 3, it came out. Done. Now, this is for the first, this one. For this one, we got value. Now, I need to generate for C of 0, 1. If you want to generate for C of 0, 1, what I should do? What change I should make here? I should make a simple change here. In this place, I need to put 1. In this place, I need to put 1. In this place, I need to put what? 1. Okay. So, how to get this? That means if I write it C of 0, 1 plus equal to A of 0, 0 into B of 0, 2. 1 into 2. A of 0, 1 is multiplied with what? B of 1, 1. A of 0, 2 multiplied with B of 2, 1. That means if you want it, you can convert into a loop. Simply you can convert into a loop, right? So what I can do, simply put here in this place a variable j. J, make it j here. J. Make it j. Make it j. Where j has to be varied from 4. J is equal to 0. J is less than what? How many times? 2. 2 is nothing but column of the second matrix. C2. Right? J plus plus. By this, I got a solution for these two. Now I need to go for the next row. That means if you want C of 1, 0 value, what you should do? A of 1 needs to be multiplied with B of 0. If you want for the next one, what I need? 1, 1. A of 1 needs to be multiplied with this column. Correct? So for simple thing, same thing you need to do. Therefore, I need what? Another index is needed. I need to change here. I'm going to make here I. I'm going to make here I. I'm going to make here I. Where my I is going to vary from I is less than what? row of the first matrix. Got it? Yeah. Remember that? Okay. Now you saw all the elements of the matrix how many times? More than once. If you want to see all the elements of the matrix more than once, use a nested loop in a loop. This is a nested loop. Loop it. That's it. Okay. But first is you write down what you're going to do, then you write the code. Till that, don't write the code.